Okay, this is section 9.2. This is the first problem from the class examples. Let's look at it and work through it. Data on the weights in pounds of the content of cans of diet soda versus the contents of cans of regular version of soda is summarized to the right. Assume that the two samples are independent, simple random samples selected from normally distributed populations, and do not assume the population standard deviations are equal. Complete parts A through B. Use 0.05 significance level for both parts. Alright, it says test the claim that the contents of cans of diet soda have weights with a mean that is less than the mean of regular soda. Okay. The diet is less than the regular. That's what we want to test. So it's equal and less than. Okay, now we'll run the test very much like we did in 9.1, except this time we will be running a T with 2, and we've got summary data. Our sample mean is right here for the first sample, and that's 0.79747, and the sample standard deviation is 0.00439. The sample size is 33. The sample 2, the regular sodas, the mean is 0.81232. The standard deviation is 0.00753. The number in the sample is 33. We put this in just like we did before. We will choose what is less than, and we compute. All right, the T here is -9, and remember, 2 decimal places, 0.79, because of that 7, rounding that 8 up. Okay, the p-value is right here at the very end, and that is 0.000 to 3 decimal places. Okay, since the p-value right here is less than the significance level, we can reject the null hypothesis, and when you reject the null hypothesis, there is sufficient evidence to support the claim that the cans of diet soda have a mean weight that are lower than the mean weight of the regular soda. Okay, now part B wants you to take the same test and same data and use it in a confidence interval. So go to options. We can edit. Since we've already got it all in, we don't want to have to put it back in. We want to go to the confidence level, and it says to use the 0.05 significance. That's the 95%. Okay, we've got a lower and upper limit. The lower limit here is -0.018. Put this 3 places. The upper is -0.012. Notice that both of those are negative. Does the confidence interval support the conclusion of the test? Okay. Yes, because the confidence interval contains only negative values.